Hi, I'm Dicle. I will talk about abstract, design of the coil, and future work.
Hello, my name is İrem. I will talk about construction of the coil, discharge terminals, block diagram, and the basic circuit.
Hi, my name is Gizem, and I am going to explain our powerful coil circuit on breadboard. And also, I am going to show you what happens when we give power to the circuit.
Abstract. Problem of this project is understanding and implementing a solid-state Tesla coil. Aim of the project is to learn and understand solid-state Tesla coil and building one. This coil invented by Nikola Tesla. Coil specifications are high voltage, low current and high frequency. Usage areas are lighting, phosphorescence, X-ray production, high-frequency alternating current, electrotherapy, and wireless electric current transmission. Today, those coils are used for entertainment and education. Design of the coils. For secondary coil, 0.15 mm copper wire is used, and the coil diameter was taking 7.5 cm to get a higher inductance value. The coil inductance value was calculated with different tools, which are Tesla Map and an online tool reference 5, and compared with each others, and the real value measured with LCR bridge. The results were given on the next slides. For primary coil, parameters were found experimentally according to sparks and wireless electricity transmission quality.
Our primary coil is wrapped on 10 cm diameter cylindrical shaped cardboard. The secondary coil was placed inside that cardboard. At the beginning, we used coaxial cable, but the copper wire inside of the coaxial cable was too thick. Because of the resistance of the conductor was very low, we observed that the copper wire drove really high current from the power supply. Because of this reason, the supply was broken. So we decided to choose thinner jumper cables. Our secondary coil is wrapped on 7.5 cm diameter PVC pipe and 0.15 mm copper wire is used. Winding of the coil was carried out at the transformer production center named Polatrafo. At Polatrafo, the thinnest wire that could be wound was 0.15 mm thick. Since we wanted to obtain a high inductance coil, we chose the diameter of the PVC pipe wide and the coil wire thin. At the discharge terminal, we put a plastic on the secondary coil, and we nailed a nail on the top of the plastic. To see the sparks, the red cable is grounded. Thus, arc jumps can be seen in between the red cable and the nail. The coil circuit on the left side was the first circuit that we built. This circuit was named as Slayer Exciter Solid State Tesla Coil, and it works with the principle of feedback. It had low range of wireless electricity transmission and very weak sparks. So we decided to build more powerful coil circuit.
This is the powerful electronic circuit design on multisim, and the circuit is going to be explained in the following slide, which is block diagram of design.
This is the block diagram of our design. Our design starts with DC power supply and goes to the voltage regulator. We use voltage regulator because when we read data sheets of the timer and MOSFET driver, we saw they are working with 15 volts, and we needed to use two different voltage values. After MOSFET driver, we have MOSFET primary coil and the secondary coil. Our secondary coil's lower terminal is connected to MOSFET driver's input, and it acts as a feedback circuit. The upper terminal is connected to nail. So, at the end, we can see the arcs between nail and grounded cable.
Today I am going to explain to you our coil and its circuit. In here we have 30 volt 3 ampere DC power supply, and this is our coil. In the discharge terminals we use a nail and a cable with ground. On the breadboard at the beginning, we have a voltage regulator with cooler, and this voltage regulator converts 30 volt to 15 volts. After the voltage regulator, we have 555 stable timer, and we feed this timer with 15 volts, and also we feed the MOSFET driver with 15 volts, and this timer circuit is connected to MOSFET driver with 100 ohms, and this MOSFET driver uses the timing pulses of the timer to drive the MOSFET. And our MOSFET has a cooler because when you give power, it produces a lot of heat and you need to cooling it. And after that, as you can see, we have really big capacitors to store the power, and also in between the primary coil terminals we have really small capacitors. And that's all for the circuit. To show you the sparks better, we wait until the night. Let's give power to the circuit. Those are our sparks. And let's show the wireless electric transmission.
About future work, we are going to rebuild the discharge terminals, set the circuit to PCB from breadboard, find the plastic material to wrap primary coil, and want to build a platform for placing the coil. You can see our project schedule in here. According to our schedule, till the 27th of April, we should observe arcs in between the discharge terminals and also check wireless electricity transmission with a bulb. As you can see in the previous slides, we already completed those tasks. With building the powerful circuit design, the quality of arcs and wireless transmission are improved a lot. You can see our references in here. Thank you for your attention.